So what I've got here is some project that's all set to go that's going to start talking about arrays. Anybody used arrays in Java before? Sort of, kind of, because you had to. So here's some array. That would be just a single variable. In Java, if you want more than one of, you say that. Okay. If you're a C programmer, you would say more than one of, like that. Okay. Same deal. And Java actually allows that syntax. You can put those square brackets on either side. If you put them on the right-hand side, people will know you're a C programmer. All of the cool Java kids actually put it on the left-hand side like that. Okay. So there's my array. How much space is there in that array? Good guess, but wrong. There's no space there. Yeah, I want to fight for strict questions. No space at all. So if you want to make the space, what do we use in Java to make space? There's our friend, the new operator. We say new integer array of some size. Okay, so the size goes there. And then you can do something like, say, an array sub 5 as you can see, my typing hasn't improved. Get all those nasty insert keys off. Get rid of the help. An array sub 5 gets some value like 10. Should use a number other than 10 just so it looks a little different. And maybe we'll do one more. Some other number. If you want to see what it looks like, you can always use the debugger. I'll put this at the start and run with the debugger and see what's in there. So we'll create the an array variable with one step over. There's the array. If you look at it, it's been created, and there's the 10 items, numbered 0 through 9. Okay, so you can use the debugger to crack open an array, and then if you plop something into one of those positions with a step over, it gets filled with the value. Okay, so the debugger is your friend in terms of seeing what's in an array. You can always crack it open and have a look at it. Nothing exciting there. Let's try making another one. Use a slightly different notation. So an integer array of some other size. So if you want, you can combine these two lines into one line, okay, which is what you'll quite often see as a shortcut. So there's an integer array. You could make a floating point array, change that to float and that to float, and you would now have a floating point array. Let's try something else. An array sub 212 gets some value. How about that? What happens if you do that in C?
Just go to a random place in memory.
Well,
Not random, but place in memory that's not supposed to be accessed.
Well, remember that way back when that we said when you take, you know, I want number 19, all that happens is you take 19 and add it to 302, and that's the locker number that you end up at. And that's all that C does when it gets translated to assembly code. No matter what you put in the subscripts, it just adds those two numbers together and says, oh, that's the position that you want. If you're lucky, that position that you picked is no longer any place that's valid in memory and your program dies, which it should. If you're unlucky in C and you run off the end of an array, all that happens is some position in memory, whatever it happens to be, just gets magically changed. Okay, so the data gets corrupted somehow, and you might never know, right? I mean, it's just like Johnny forgets that he's supposed to be at this locker, he gets the locker number wrong, he goes, he breaks in, he throws out whatever stuff is there, puts some other stuff in. It might be 2 weeks later that the kid who owns the locker comes along and tries to use it and discovers that it's not the same stuff anymore, but maybe just tries to use it, thinks it's his jacket, and just uses it, never knowing anything different. Okay? So one of the problems with C coding is that if you ever choose a wrong subscript, even if it's just one off the end, which is what's the most likely thing to happen, you still end up destroying somebody else's stuff, and it just happens to be whoever was adjacent to you, okay, which is a bad thing. What happens if you do it in Java? Well, let's just give it a try.
Recreate a new array and flush out the old one.
We'll just run this one, and there's what you get. Down at the bottom, it says array out of bounds exception, and it gives you the line number that was the problem. So that's the line number that's the problem, and the value that's out of bounds is the 212. Okay, so that's a good thing because it means that it doesn't ever allow you to go outside the bounds of an array. What happens in C, by the way, if you do this? Put a minus sign on the front of there. Still just does the same calculation. That's perfectly valid in C to go backwards from the base address, which is probably a bad thing, but C allows that one also, even at compile time that doesn't check. Okay, so the same with Java. Java will kill it on you instead. That's just not something that you're allowed to do. Okay, how do you know in C how many items you've actually allocated for the array?
Keeping track yourself.
You have to keep track of it yourself. So whenever you make the space for it, you just have to carry around a number someplace that says that's the amount of size that I used for that array. The one thing that we have in Java that's a little bit handier is you can do system out print line of an array dot length is about the only thing it'll give you. And you can actually print out the size of the thing, which in this case is the number of items that were allocated, which was the 10 spots. Okay? So the only smart piece of information that an array provides you is to tell you what size that you allocated with it initially. You still have to keep track of the dividing line of how many of those spots have I used, but it will tell you what the maximum number is that will fit in that array.
If you take out dot length, would it print the entire array for you?
It might, whatever the toString happens to do, or print out its address, something like that. You can still use for each. I equals 0. Actually, we'll do it both ways. For int and int in an array. If you want to use a for each on an array, that's allowed. Okay, so we can run that one, and that will work. And print out all of the values in the array. Okay, so that's fine. But the problem with for each is that arrays by their very nature are interested in what the subscript is, and for each doesn't allow you to do that. So most of the time when you're working with actual arrays in Java, they're probably going to be less than full, or you're probably just going to want to use the regular notation. So we'll use the counted loop, I equals 0, I is less than, and now here's where we can use an array dot length, and you can go through and print them out. And this time we have to say an array sub whatever I happens to be. So usually you'll use subscript notation, in this case, the counted loop, to get at things in an array. And so there's two versions of printing it out, either the counted or the not counted version. Okay. How about arrays of objects? So I just happen to have a crow class here. So here's one crow. There's the way I would make one crow. How would I make a bunch of crows? In array notation. Just like with float, you change this word to crow instead, so you could have crow, a bunch of crows. There's an array of crows. How many items are in that array? So let's make a new crow array that will hold 50 of them. Oops. Doesn't like. Oh, new would be helpful. What's the current value of crow sub 0? Why don't we just try and print it out? So that would be murder sub 0 dot. Crow has a get name, so we can retrieve its name. Just do it that way. Actually, I'll do it the longer way just so that you can see it. Crow, a crow. Some crow, I guess. Just going to move that up there so that I can get it out of the print line so you can see it. And then we'll print it out. Oop. Some crow dot get name. What's it going to print? It's a trick question. You know it's got to be a trick question, right? What's it going to do? So in this case, it died with a null pointer exception. The null pointer exception is at line 34. Null pointer exception, anytime you see it, all that you have to do is look at variables that have something to the left of the dot, and what it's saying, since there's only one dot here, is that the variable some crow doesn't have a value. No crow has been made yet, the array is empty, there's a null in there, so you can't say null.getName when you don't actually have a crow in hand to ask. Okay, so notice the thing that's different about arrays of integers versus arrays of objects is that with arrays of integers, since you're just putting a number into the integer array, you can use the thing immediately when you make it. But when you make an array of objects, you're making a space to hold variables that are going to have values, so you need to fill variables into those array positions in order to make use of it. Okay? So in this case, what we have to do is we actually have to fill that thing with a value. So someplace along the line, you have to say murder sub 0 equals new crow. I had to do it, it was there. Okay? So now there's actually a crow that's sitting in the array, and now I can go through and print out the value of whoever it happens to be, and that will work. How about printing out all of them? We'll just get rid of this and we'll write our loop. I is less than murder.length. Go through all of them and we'll print out all of their names back to murder sub I dot get name. Run source format on that. There we go. How about that? Is that going to print out all of the crows? Let's just run it and see what it prints out.
After shell, there's nothing.
So this says go through all of the things that are in the array, but it's only the first one that has a value. So you get a null pointer exception in this case when you try to print out the number 1 position, because there's no crow that's ever been put in the number 1 position of the array. Okay, so again, there's that difference between integer arrays versus arrays of objects. Integer arrays are pre-filled with basically zeros in it. If you put different numbers in there, you can still always print out an integer array and see all of the values that you've got in it. But as soon as you move to storing arrays of objects, we now have to keep track of how many are actually in there, right? So we'd have to start to make a variable int actual number. So the actual number of people in that array is just 1 at this point, so that now you can do your loop not to the maximum number that are in there, but the actual number that are in the array.
Could you set a default value for the object name just so you can continuously print out to check your look? Like
You could fill it with empty things,
Yeah.
but then you'd have to have nameless crows in there, right, and you'd still be in a sort of a weird situation. And so what tends to happen is this sort of, now it will work, right? But notice that what we've got is we've still got this bookkeeping, because this actual number value here says I allocated this many positions, but here's the line between the used versus the unused, and now you've always got to carry that thing around with you whenever you're dealing with the array, because that's the only way that you can know how many things are really in there. Okay, so if we add another one in, murder sub 1 is some other crow. Now I'm running out of good puns. I can't think of another crow. So we'll just do this one. now the fact that I've added one crow in there, it means that I should now turn around and bump up my actual number.
Wouldn't you just throw that in the crow class?
You don't want to put it in the crow, the crow doesn't care. The question was, why couldn't I put that in the crow class? And it's like, well, the crow doesn't care how many crows are there, and it might be a different array, so you can't possibly know. But notice that what just happened here. The interesting thing is now every time we add something to the array, we now have another number that belongs with the array to keep track of how many things are actually in it. So what do we do in Java when you have two variables that belong together? You make a class because you want to make sure that every time somebody says add to that array, that that number is actually keeping track of the number of items that you've actually got in. And so now we've got to pair up those two things and make a class to handle it, and let the class take care of manipulating those two variables in the array for us. And so that's the whole start of the ball game for the term of, okay, now we basically have to turn around and write array list to manipulate this array for us and do all of the good things that we want it to do. And with that, we're done for the day.